Thank you. Welcome to my presentation in ACI Concrete Convention Spring 2022. My presentation topic is about performance evaluation and load rating of retrofitted impact damage non-composite steel girder breach deck. I'm Mezanur Rahman going to present today. I would like to acknowledge my supervisor, Dr. Nubi Yazdani, and my co-authors, Dr. Usias and Dr. Ikram Ifez, for their help. And moreover, I would like to thank ACI committee to give a chance to share my work. Composite-based construction has been practiced since 1930s. Many of them are old and not designed for composite action. Continuous strain profile can be assumed throughout the intersection in case of composite breach. On the other hand, in case of partially composite breach, we can see there is a disruption in the strain profile because of the less shear connector. There is no chance to develop fully plastic moment at the interface of the composite beam while it is partially composite. And in case of fully non-composite breach, although the strain profile or the curvature of the steel and concrete sections are assumed to be same, but each of the element bends around their own neutral axis. So in case of non-composite breach, each structural element bends around its own neutral axis, but in case of composite breach, concrete deck and the steel beams function as a one element to resist the live load by transferring shear force between the two interfaces, for example, deck and steel girder. So according to AC infrastructure report, USA has more than 670,000 bridges. Among them, 7.5% of the bridges are structurally deficient. So this structural deficiency could be due to fire, explosion, poor design, construction error, poor maintenance, time-dependent deterioration, or corrosion, or impact of vehicles. According to Federal Highway Administration, vehicle impact or the collision collision is chosen one of the top 3 causes of breach failure. So for this study, we choose such kind of impact damage breach. The bridge name is San Francisco Bridge. It is situated over I-30 near east town of Dallas, Texas. So the bridge has 2 bounds, northbound and southbound, and it has 6 spans symmetric around the center line of the bridge. So in 2017, the bridge was hit by a 18-wheeler wrecker and pierced through the concrete, pierced through the girder and also pierced through the concrete deck. You can see on the screen how the damage was at that night. So as the bridge was built near 60s, the vertical clearance of the bridge is too low. For the vertical clearance of the bridge right now is 13 feet 9 inch. So the damaged section performance will be different from the undamaged one. Hence, it is necessary to understand the overall breach behavior so that efficient and reliable repair methods can be applied throughout such kind of breaches. So objective of this study is to evaluate the performance of an impact damage breach through non-destructive evaluation and static load testing, propose a distinct approach to load rate the non-composite concrete deck over steel girders by incorporating NDE data in the load rating procedure, develop an advanced and approach load rating of a non-composite breach after retrofitting. So prior to the load test, a detailed instrumentation plan was prepared to optimize the load test. Affected spans were chosen. Total 28 strain gauges and 12 rotational tilt meters were installed at the bottom installed on the girders. Top and bottom strain gauges are installed on the inner surfaces and of the top and bottom of the girder. So we measure strain data through the strain gauge, and we measure the end rotation of the girders through tilt meters. 5 critical sections along the length of the girder were instrumented. A diagnostic close test was performed on a continuous span in 2018 November. Two types of static load testing were performed. First, core speed test, and second, stop location test. Crawl speed tests were carried out where the truck was moved less than 5 miles per hour. So we kept the speed of the vehicle low so that no dynamic effect can produce on the bridge while the live load is moving. 4 different paths was chosen to record the strain response of the girder. For example, path 1 was chosen so that it can produce maximum strain on girder A and B. In case of path 2, it can produce maximum strain response on girder C and D. And we perform the load test at night because there is less traffic at night, so we prefer that time. As a part of non-destructive evaluation, ground penetrating radar and impact echo was used. So with GPR, we determine river depth, location, and spacing of the river on the concrete or in the concrete deck. And with the help of impact echo device, we detect the delamination of the concrete deck. So after GPR data and IE data analysis, we see that around 70% of the scanned deck area has top river cover more than 2 inch. But in the as-built drawing, it was mentioned the top river cover was 1.5 inch. So the moment capacity of the deck is compromised in that scenario. Moreover, from the impact echo, we saw around 42% of the deck is severely delaminated. So the red portion, the red color in the impact echo analysis shows the severely delaminated areas. Then the deck rating was performed according to ASTO manual for bridge evaluation for HS20 truck. The rating factor equation express capacity minus factor dead load divided by factor live load and impact factor. So how does it work? If the rating factor is more than 1, then it means the rated element is able to carry HS20 load, and if it is less than 1, so the rated element can't take HS20 load. So we incorporated GPR data and impact echo data to find out the capacity of the deck. So after doing the load rating, we came up that the bridge rating was 23,000 pounds in inventory level, and in operating level it was around 39,000 pounds. So in this case, we can see that the rating factor, as the rating factor is less than 1, so we need to post load on the bridge, or we need to go for urgent retrofitting options. So prior to applying a retrofitting strategy to a full-scale bridge, a finite element model can utilize to evaluate the efficiency of the retrofitting options. Sometimes experimental studies for different retrofitting options can be time-consuming, expensive, and have some constraints. So FEM model is a suitable option to get rid of that kind of situation. Through FEM model and cost analysis, bridge owners can take decision which retrofitting is a suitable option for deficient bridges. So a full-scale bridge model was prepared in Abacus software. So cohesive contact properties were used between the girder and deck interface. A river were embedded in the deck. Boundary condition was assumed according to the field support. Then the load from the truck was used as a static patch load, and optimum meshes was selected based on mesh sensitivity analysis. The model was calibrated with field experimental data. Strain and rotation data collected from the load test was used in this purpose. We can see the neutral axis location was close to the experimental result. Four retrofitting options were selected to do the comparative study. Concrete chipping was used to increase the negative moment capacity of the concrete deck, while CFRP laminates, GFRP joists, and steel joists were used to increase the positive flexure capacity of the deck. So single strip of the deck was used to find out the capacity of the retrofitted deck, So the rating showed that the deck was able to carry HS20 load after applying all the retrofitting methods. Then a cost-benefit analysis was performed to choose the best retrofitting options. In cost analysis, we considered all kind of costs to retrofit the concrete deck, like material cost, labor cost, transportation, traffic closure cost were considered. Based on the cost analysis, concrete chipping plus CFRP is the most suitable options in this study. So as a conclusion, we can draw that 82% of the scan deck area has top river cover between 1.5 and 3 inch. IE contour plot demonstrate structural integrity and the strength of the deck has compromised. A distinct load rating approach was established to load rate the deck. And additionally, Girder rating was determined using the live load distribution factor acquired during the load testing. And finally, the deck rating after retrofitting was greater than one in both inventory and operating level, indicating all the retrofitting options are applicable in different circumstances. However, CFRP laminate was the most cost-effective choice in this case based on cost analysis. Thank you for patience hearing. If you have any questions.
Thank you, Mohd, for your presentation. I appreciate that. So we have time for questions. So if anyone from the audience has a question, please step to the microphone so we all can hear. Please, absolutely.
I just have a quick question. So for the finite element analysis, like which computing software are you using?
I used Abacus.
Okay, thank you.
Yeah.
Thank you for your presentation. I just have a question. What kind of the interface did you consider between the FRP laminate and your model in your finite element model in Abacus?
Okay, so I considered two kinds of as the bond. I assumed the first one is I assumed the bond is perfect, so I used first one tie constraint, and the second one I used cohesive interaction.
Okay, thank you.
Sure. All right. So do we have any questions from online audience?
Hi, thank you for your presentation. I was wondering if you considered or how did you model the delamination of the rebar in the concrete?
Okay, so that's the interesting question. So we are still working on that one because it is quite difficult to input the delamination in the Abacus model. So what we did, we calibrate the model based on the GPR and impact echo data we get from the load test. So we're still trying to figure that out. That is the further recommendation of our study. Yeah.
Thank you.
Mm-hmm. All right. So on one of the slides, maybe I missed this information when you were presenting, but you said that the cost over benefit of using different methods. Mm-hmm. So I understand the cost. Can you explain what is the benefit? How did you calculate the benefits there? Oh,
so I calculate the benefit based on the rating factor. So like if I go back to my slides, so I choose the inventory level as the benefit and I choose the cost as a cost.
So basically the benefit is just explain in terms of time, which one it takes less time to get operative, gets ready to go.
Actually, I'd say like which one might increase the capacity more, but it will, yeah, you are correct. Like it will take less time and less cost.
So the time and capacity, so they create like a different level of capacity as well.
Mm-hmm, yeah,
time and
like
capacity.
Each retrofitting options create different kind of capacities.
Absolutely, that makes sense. Awesome. Thank you for the presentation.